Hi all! So in this video we're going to look at question 3 from the practice exam 3. And in this question it looks like I'm trying to figure out a quartile. So some quantile, but in particular we're looking at a quartile. So let's first figure out what our distribution is. So we're letting x be the Frechet distribution. Here we haven't really gone over this, but the Frechet distribution is basically the distribution whose probability density formula is given by this formula here. So in other words, this is our f sub x of x. So you're given what this is. So in other words, it's a continuous one. And here the range is kind of weird. My range is from m to infinity. So it's not the standard range. It starts at whatever this m is, and it goes to infinity. And here I'm basically telling you, here's our numbers. Our m is 2, our alpha is 3, and our s is 4. And the question is, well, what is the third quartile of x? So first what I need to do, I need to calculate CDF. Calculate CDF. So here, what is a CDF? So f sub x of x, this is just the probability that x is less than or equal to some x. So in other words, here, I'm going from m, because my range starts from m, and I go all the way up to x. But here, there's another thing you kind of have to note, and that I can't use x's in my equation here. Because I already have a variable x here. So I'm going to convert these to y's. E to the minus y minus m over s minus alpha. And here I'm not putting in the numbers right away, because it's just going to be harder to mesh with numbers for me. It's easier for me to see things without numbers. So I just do no numbers. You can obviously plug things in right away if you wanted, but that might make things a little more difficult. It might obfuscate some of the things inside. So from here, I might be like, oh shit, this is nasty, right? Like looking at this, it's a variable in y, and there's a lot of stuff happening. But I kind of see, so the hint for me that I should probably be using substitution is I have minus alpha here, and then minus alpha minus 1. So it feels like a derivative of this part up here. So in other words, I'm just going to naively, I'm going to let I'm just going to let this be equal to this. Y minus m over s minus alpha. And let's take the derivative. What happens if I take the derivative? So first, the derivative of the exponential is always itself. So this is just z, right? That doesn't change. I'm not going to rewrite it, but you could if you wanted. It's the same thing. So we have z times, then I have to take the derivative of the exponent. So the derivative of the exponent is minus times minus alpha, right? And then I need to subtract 1 from the exponent, minus alpha minus 1. But now my inside isn't done yet, right? So I need another chain rule. So I need to now take the derivative of the inside, which is just y over s minus m over s. So it's just 1 over s. And then dy. So this is my derivative. Now let's plug this in and kind of see what we get. So this is equal to, here I'm going to keep track that these are my y's, so I don't screw this up. Alpha over s, y minus m over s minus alpha minus 1. And then this part we said is z, so z. And now we're going to plug in for dy. So dy is equal to dz divided by all of this. So we have z times minus minus becomes positive, so it's just alpha times y minus m over s minus alpha minus 1 times 1 over s. Now here you're going to notice a lot of things cancel. The z's here cancel. Here, I should do this in a different color. The z's cancel. Here the alphas cancel. The 1 over s's cancel. And also this whole thing cancels. They're all the same. So basically everything cancels. So in other words, I'm left with y equals m, y equals x, 1 dz. And here this is not 2, this should be an integral you know how to do. If you don't know this one, I don't know what to tell you. So we have to plug these in, but now I know what my z is, right? This is e to the minus y minus m over s minus alpha from y equals m to y y is already there, so m to x. So now we plug these in. E to the minus x minus s over s minus alpha minus e to the minus m s minus alpha. So here I'm left with this minus e to the minus, here I have 0 over s to the power of minus alpha so 0 to the minus alpha. But notice what happens here. I have a 0 to a negative alpha power, right? In other words, this exponent is really, really big. So what is this? So this part here, let's do this. Limit as b goes to 0, e to the minus 1 over b, b to the minus alpha. So what this is limit b goes to 0, 1 over e to the 1 over b. So 1 over b, this is going to get really, really big. So this is going to basically be limit as c goes to infinity of 1 over e to the c. And this is going to go to 0. So basically this part goes to 0. And I'm left with e to the minus x times m over s minus alpha. And here, if I want, I can now plug in my m, my alpha, and my s from before. So here I'm left with e to the minus x times m is, or minus, sorry, not times, minus 2 over 4 to the power of minus 3. But here, notice how this just gives me the CDF. I really want the third quartile. So 2, I want to plug this into the third quartile, so it's 3/4, right? Third quartile is the 3/4. So basically, I just need to solve this equation. So I have e to the minus x minus 2 over 4 to the minus 3 is equal to 3/4. So in other words, minus x minus 2 over 4 to the minus 3 is the natural log of 3/4. I'm running out of space, so I'll just do this here. So we have x minus 2 over 4 is equal to minus natural log of 3/4 to the power of minus 1/3, right? This minus third, I need to multiply by minus 1/3 in order to cancel it. And then I'm left with x is equal to 4 times natural log of 3/4 to the minus 1/3 plus 2 to kind of get my final thing. Let me double check I did not screw that up. That looks okay. And if you plug this in, you get 8.059299. And that is my final answer. So yeah, so as you can see, it's a little bit more complicated, but it shouldn't take too long. It's definitely doable within time frame. Okay, so that's it for question 3. Question 4 we will see in the next video. So I will see you then. So yeah, bye.